Yes. Let us start the derivation of first derivation of the equation of the circle in this particular conic section. Just open your classwork book and pen, note down the points as and when I discuss it. If you do not get a time to note down, then you can mute the video and note down it and continue. Okay. Let us start derivation of equation of the circle. To derive equation of the circle, equation of the circle with center HK of the circle with the center HK and radius R. That's very simple equation. You can understand it very easily. For that, we will go to the Cartesian coordinate system. Generally, this particular coordinate geometry was developed by René Descartes. You may be knowing about him. And he showed whatever graphs you are drawing at school level or elsewhere, these are done in a Cartesian coordinate system. It will have two axes, as you know, even in trigonometry also you learned this is called as y-axis. Any derivation of the coordinate geometry are done in a Cartesian coordinate system only, named in the honor of René Descartes, Cartesian. Let us consider a fixed point in the plane, let me call it as O, and a moving point, let us take moving point Pxy in the plane, because we are taking the locus. What is the definition of circle? Try to recall. A circle is the locus of the moving point. What do you mean by locus? Locus means the path traced by the moving point, which moves us that it's a distance from the fixed point is always constant and is called as radius. We will use the same definition and derive very quickly. Here we have taken that center is, let me call instead of P, I will call it as Q because O is already there. Let QHK be the center, fixed point, and Pxy be the moving point. It is moving, satisfying certain geometrical condition. What is the geometrical condition? In the definition of the locus, the geometrical condition is its a distance from a fixed point is always constant. It is a very simple geometrical condition. Based on that, using distance formula, we are going to derive the equation of the circle. And after drawing the diagram, let us consider let Pxy be a moving point in the plane. Try to understand how to derive moving point in the plane. Understand, don't by heart. Pxy be a moving point in the plane, in the Cartesian plane. Whenever I say plane, you consider that it is a Cartesian plane. Let QHK be a fixed point. QHK be the fixed point. Okay. Understood this one? Now see, now you have to come to the definition. Recall the definition of the circle analytically. That is, it's a locus of the moving point, means path traced by the moving point, satisfying which geometrical condition? Its a distance from Q is always R. By definition of locus of circle, directly go to the definition. By definition of locus of circle, you can say that PQ length, in particular, PQ length is always positive, let me take modulus, is always equal to R. You studied in the straight line, Pxy is 1 point, QHK is what is the distance formula? Using distance formula, can you get the length of PQ? Using distance formula, you studied in the straight line, what is the distance formula? Recall, distance formula. What is the distance formula? Suppose x1, y1, recall, suppose x1, y1 and x2, y2 are the line joining the 2 points. What is the distance formula? You know, is a root of x2 minus x1 whole square plus y2 minus y1 whole square. We will use the same formula, root of x2 minus x1 is x minus h whole square. You can take in any order you want, plus y minus k whole square is equal to r. Just square it, the equation is ready. Squaring on both sides. Squaring on both sides. Squaring on both sides. When you square it, the root eliminates and you are left with the equation of the circle ready. That is, let us write this equation of the circle: x minus h whole square plus y minus k whole square is equal to, here root eliminates, here you have to write the square. Yes, the equation of the circle is ready. This is required equation. This is a required equation. I hope you understood the derivation. Simple derivation of the equation of circle. This particular form of the circle is called as central form of the circle. It is called as central form of the circle, and there are different forms of the circle. In that, this is the one of the forms called as central form of the circle, and with HK as center and radius here. Remember this standard form. By comparing with this standard form, we are going to get the details, and we are going to solve the problems. Let us see some few elementary types of the problems on this circle.